All right, let's get started. So yesterday we managed to go through, I think, the first 3 problems. Hopefully today we'll be able to do another set of problems. So we are given this. Can people see my screen? Can people see my screen?
Yes.
All right. So we are given this, and then we are asked to find to prove that A, B, C, D is a parallelogram, right? So that means we might need to revise our properties of parallelograms. So we know that opposite sides are equal and parallel, right?
Opposite.
So opposite sides are equal and parallel. And then the angles at the diagonals, as in like this angle and that angle. So we can say opposite angles
Are equal.
are equal as well. And then what else can we say? There's something about diagonals, but we are not going to use that here because it's not going to be useful. We don't have anything that's a diagonal here. All right. So I think these are the properties that we are most likely to use. So if we check, here we are given this angle 65. We are told that AF is equals to BF. Because they have the same number of lines, so it's 2 lines, 2 lines. That means this line is equals to that line, 1 line, because they have one stroke like that. And then we're also given that this is 65. We're also given that this is 115. So in order to prove that this is a parallelogram, what we can try doing is finding out that those 2 angles are the same, and maybe we can also prove a side or 2, or we can also prove this. There's someone's mic that's active. We can also prove that this angle is equal to that angle. So let's see how we can go about it. So firstly, in this triangle, in triangle ABF, we can say angle B is equals to 65. The reason for this, we're having these are angles opposite equal sides, like that. So that means this is equals to that. This is an isosceles triangle. So that means here we are having 65 like that, right? Everyone okay with that one?
Yes.
All right. Now let's check. Here for angle E, this is a straight line, angles on a straight line. So let's see if we are able to get this angle over here, right? So we can call it E2. So we can say 115 plus E2, it's equals to 180. Those are angles on a straight line. Angles on a straight line, that means we can say our E2 is 180 minus 115. And what do we get there?
30.
180 minus 115. We can't get 30.
Oh, 115. 65.
65.
65.
So that means this is 65. So this is 65 over there. And then since this side is equal to that side, we can say that angle D is also 65. The reason for that, those are angles opposite equal sides. So we can see that EC or CE, it's equals to CD, like that. Right, all good. So now we have shown that this guy over here is also 65. So we have proved this part over here. So we can say, therefore, A, B, C, D is a parallelogram because we got this property true. The opposite angles are equal. So we got this being opposite angles were equal or are equal. So that could count as our proof. So another route you could have followed, you could have used congruency somewhere. Could have used congruencies somewhere, I believe. Yeah, could have used congruencies somewhere. And you could have gotten that this is still a parallelogram. Or you could have used co-interior angles somewhere. But yeah, there are many ways to go about it. You just have to find one that will prove one of the properties. Any questions on that one? Any questions? Anyone who got lost?
No, sir.
All right, moving on.
No.
For number 5 on your questions there. Number 5, this is what you have. You're told that you're having PQRS and you're told it's a parallelogram. So PQRS is a parallelogram with QPR. Remember we said the one wearing the cap is the angle they are talking about. QPR is this angle with its 50 degrees, and you're having QSR. QSR over here is 40 degrees, supposed to prove that that is a rhombus. Right, properties of a rhombus. Properties of a rhombus.
4 sides.
Yes, it has 4 sides. It's a quadrilateral. What do we know about the sides?
They are equal.
All right, so our sides are equal. So all sides are equal. Equal, yeah. Equal and
They are
parallel.
parallel.
Yes, equal and parallel. And then what else?
The diagonals bisect each other at right angle.
The diagonals bisect at 90 degrees.
Yes.
What did I write here? Bisect. Wow. Okay. So diagonals, they bisect at 90 degrees. Okay, do we have anything else? Okay, another thing we can say, the corner angles are not
Angles are equal.
the opposite. What did you say?
Opposite angles are
Opposite.
equal.
Opposite angles are equal, so we're saying this is the same as that, and likewise that it's the same as that. All right. Okay. Let's see. And then what can we say about the corner angles over here?
They are 90 degrees.
They cannot be 90 degrees. Immediately, if it becomes 90 degrees with these properties, then this is a square, not a rhombus.
The diagonals bisect the corner angle.
The diagonals bisect the corner angles. Is that true?
No.
If we say it bisects the corner angles, we are saying this is also 40. Okay, that's fine. Okay. So diagonals bisect the corner angles. So they also bisect corner angles. All right. And then, okay, that's fine. Let's see if we can work this problem, and maybe we might have missed a property also. Right. To prove that this is a rhombus, we just need to prove somewhere along these lines. Right. So let's see. So already this, we are told it's a parallelogram. That means this side is parallel to that side is parallel to that, like that. Right. Also, if it's a parallelogram, we know that side is equals to this side is equals to that side. So our mission here is to prove that this side is equal to that side, and also the other sides. So let's check. All right. So is everyone okay if I'm gonna say that Q P R it's equals to what's this? P R S, like that, as in like this angle, it's equals to that angle. Are we okay?
Yes.
Yes.
Alternating angles. So you can say those are alternating angles, right? So that means this is also 50 over here, right? And then can we name this O1 and say in triangle ROS, if we are looking at triangle ROS, O1 plus the 50 that we just got here, plus 40, it's equals to 180. The reason for this, that's our sum of interior angles of a triangle, like that. So we end up with O1 plus 90, it's equals to 180. O1, it's equals to 90 over here. It should be 180 minus 90, we get 90. So that means this angle over here is 90. Are we okay with it?
Yes.
So we have proved this part of
Yes.
diagonal bisect at 90 degrees. This part.
Yes.
With property, we have that one. Right. So let's check something else. Because also as for a square, we also have diagonals bisecting at 90, or is it not 90? It's 90 as well. Okay, it's 90 as well. So that means this alone cannot prove that this is a rhombus. This could say this is a rhombus or a square, right? So let's see if we can do something about our sides. So let's check. Yes.
Please, I can't see the reasons quite clearly, sir.
All right, the reasons, I'm actually speaking them out. Okay, for this one, we said it's the sum of interior angles of a triangle.
Yes, sir.
Part. You saw it?
Yes, sir.
All right, and then this one, we said those were alternating angles.
Yes, sir. Thank you, sir.
All right, all good. Let's move on. So now what we will try to do, we'll try to prove that this side over here, it's equal to that side over there. So we'll say, let's check. Are we okay if we're gonna say angle PSQ, it's equals to angle, can say RSQ, as in like this angle over here, it's equals to that angle over there. Are we okay with that one? I think we listed it as one of the properties.
Yes.
We said that our diagonals, they bisect our angles at the corners, right? Bisect angles or something like that at the corners, right? So that means this part over here is also 40. This part over there is also 40, right? Everyone happy, lab?
Yes.
Yes.
Right. And then are we okay if I'm gonna say R S Q, it's equals to P Q S? Are we able to see that one? So it's R S Q. So this angle over here, it's equals to that angle over there, P Q S, like that.
Yes, sir.
Alternating angles, right? So if we have that, that means now in my diagram, I can write this. I have 40 here, I have 40 there, right? So if I have 40 there and 40 there, can I now say that PQ is equals to PS? The reason for this would be sides opposite equal sides, like that. So now this is now an isosceles triangle. Can you see that? We have the base angles here being equal. So this means that that side is equal to that side. All good?
Yes, sir.
Right. So if that's the case, remember, we know that PQ, it's equals to RS over here, because we said that this was a parallelogram. These two are equal. And then now we just concluded that this side is equals to that side. That means this side is also equals to that side. Therefore, RS, it's also equals to PS. And then if PS is equals to this one, that means we can say RS is also equals to QR. So all of these sides, 1, 2, 3, 4, like that. If I'm if I've written them correctly. So all sides are equal, and we have the diagonals bisecting at 90 degrees. Right. Do we need to prove something else?
Oh.
All right, we need to prove one more thing, that this angle is not 90, this one over here. All right, so already we might have proved it somewhere here. So here we're at 40. So we can say that, what's that angle? Angle S, it's equals to 80 degrees, like that, which means this is not a square. So it has to be a rhombus. Has to be a rhombus. Does that one make sense?
Yes.
Right. Remember, we said properties of a square and a rhombus are the same. The only difference would be that the angles at the corner there doesn't form 90. Or they both have equal sides, and opposite sides are parallel. And the square has the corner angles being 90. It also has this diagonals bisecting at 90 and whatnot. But the only difference between the two, it's this part. So I hope that counts as a lot of proofs for one thing, like that. Any questions for that one?
Usually say how many marks?
Did they write marks on that thing? Could be 4 or 5 marks, depending on what they're actually trying to test. Could be 4 or 5 marks.
So, sir, must we write all those sums if they ask us these questions, or we are going to write the side?
Yeah, I have to write all of them because you're proving this thing now.
Okay.
So you're not assuming anything. You have to tell them that this is that, this is that, this is that. This is how I got to my final answer.
Okay, sir.
All right.
Sir.
Uh-huh.
La best match is like yes mina ne bangithola into so nginokungazi ngiqale kuphi like so say i-advice like ongasipha yona ukuthi okay where do we navigate because
Lukhanya
ngoba
makahambe please. Makahambe Ntombo Lukhanya.
Okay, we have multiple speakers over here. Okay, advice that I can give you guys is that you have to start looking at the diagram. Note what you know, isn't like here we saw that okay, this is a parallelogram, so we sort of plugged in all the properties of the parallelogram that we can identify. And then from there, we sort of noted the obvious that this guy and that guy, or what's this, QPR and PRS, those are alternating angles like that. Just to be able to use the properties of that rhombus that we're trying to solve for. So you're using properties of the shape. So right, like this one, we were told that this is, we're supposed to prove that this is the rhombus. So we sort of listed all the properties of the shape. So all sides were equal, blah, 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 blah. And then from there, we come back to the diagram and be like, okay, how can I show that all my sides are equal? Right. And then from there, this is the part that we did that. We're showing that the sides are equal. We're using, I think, somewhere here. So that means this part is done. And then we also checked this part of diagonals bisected 90. So for the one of diagonals bisected 90, we covered that one somewhere over here. And then we also used this one that the corner angles, they bisect or something like that. We used it somewhere, I think it was 40s or somewhere here. Yeah, we used it somewhere here, like that. So you have to remember all of those properties. And then from there, try to check the diagram. How can I show that this property is possible, or how this property is possible? I hope that one makes sense. And the more questions you do, the better you can see this from a distance. I hope that answers some questions.
Yes.
All right, let's try doing more, and hopefully as we do more, people will understand better. Okay. Okay, I'm having someone struggling to log in. Let me just try and find. What does it say? Okay, so for this one, we are told that we are looking at diagonals, which is PR, so PR and QS. This shape is a parallelogram, and we are told that those diagonals, they intersect at T over here. And then we are told that if PT, this is PT, it's equals to PQ over here, we can see that. And also PTS, this angle over here is 120, supposed to prove that this shape is a rectangle. So we'll start like we did before. We'll check, okay, what do we know about a rectangle? Properties of a rectangle?
All sides.
Four sides.
All sides.
corner angles are equal to 90 degrees.
Okay, so I had something about sides, but they were not saying something Okay, that's fine.
The
So corner
opposite
angles
side are parallel and equal.
So corner
Two
angles.
sides are parallel.
Okay, so corner angles. Corner angles are equal to 90. And then we're having opposite sides. Opposite sides are equal and parallel, right?
Yes.
Right. What's another one? What do we know about our diagonals?
The diagonals bisect the corner angles now go by 45 degrees. But I don't think we mentioned that one.
Okay. What else can we say about diagonals in terms
The
of
diagonals bisect each other and are equal in length.
okay, so diagonals, they bisect each other. They bisect each other and they're equal in length. All right. All right. Okay. So those are the properties that we have listed. If we have left something, we can add on later. But now that means we are trying to use these to prove for this part, to prove this shape over here. Still have people struggling to join. Okay. So here, what we know, it's from the information above, everything has been listed there, right? So we need to prove that this side, actually we don't need to prove it. We are told this is a parallelogram. So we know that this side, it's equals to that side. This side, it's equals to that side. This is parallel to that. This is parallel to that, like that. All right, all good.
Yes.
From the information we have here that this is a parallelogram, right? And then from there, we just need to show that this side over here is not equal to this side. That's one thing. So this side
Can
is
I ask? I think you blocked this angle with the red thingy.
Which angle?
Not an angle. This line there. Yes, sir. It represented the line there. It represented the type of triangle to a certain extent.
No, it's telling us the length, that this line is equals to that line. This part, it's equals to that part. So since we are using one line like that, that means also this one is equal to those lines. If we used two lines like that, we're saying that this line over here is the same as that one, and so
on.
Okay. I don't know what I wrote, but okay, that's fine. Okay, let's try and prove that this is a rectangle. We said we needed to do something about this side and this side to show that they are not equal. And what else do we need? Okay, let's start there. Right, so we can first find out this angle over here. Can you see that we have a straight line here? So we can call this T1. So we can say T1 plus 120, it's equals to 180. And there's angles on a straight line like that. Therefore, your T1 is equals to 180 minus 120. The T1 is equals to 60. So here we're having this as 60. Right. And then if this is 60, what's this angle over here? We can say PQ T, it's equals to 60 as well. The reason for that, these are angles opposite equal sides. So these are angles opposite equal side. This side is equal with that one. So that means this will also be 60 like that. Do we understand this reasoning?
Yeah, please rephrase.
We are saying that since this line is the same as that line, this angle has to be the same as that angle. These are the angles that are opposite equal sides.
Okay.
All right. So now if we have that as 60, let's check something else. We can say in triangle PQT, in this triangle PQT, angle P over there plus angle Q plus angle T are equals to 180. This is the sum of angles of interior angles in a triangle. All good.
Sir.
You're adding that one, yeah? That one and that one, yeah?
No, I'm just asking, if like there's this thing lana yabo angisho sekhona lapho bofake khona ngazi alternating angles kuze previous one.
Yeah.
What about ama-vertical angles? Uyakhona ukuwafaka nala?
Yeah, you do have vertically opposite over here.
Oh, and then oh, okay.
Yes,
No.
you can do that. As long as it's gonna help you down the way, it's fine. All right.
Okay.
So here we are saying that in this triangle we have this part over here. So let's plug in what we know. Angle P, we don't know it. Q, it was 60. T1, it was 60. This is 180. So we're having 180 minus 120. We end up getting that P is equals to 60. So if P is equals to 60, that means this angle over here is also 60. So we're having 60, 60, 60. What type of triangle is that?
Equilateral.
Equilateral. We can say therefore triangle PQT is an equilateral triangle, like that, right? So if we understand it's an equilateral triangle, it means that this side is also equal to that one, is also equal to that one. Therefore, we can say QT, it's equals to PQ, it's equals to PT, like that, right? So now we have this part. Can we conclude that since we said something about the diagonals bisect each other and equal what, then this part will also be equal to this one? Do you agree?
Yes, sir.
All right. So we'll say QT, it's equals to ST. Can we also say PT, it's equals to this one? And then PT, it's equals to RT or something like that.
Yes.
Right. But we also know that PT, this part, is equals to this. That means this and that are the same. This and that are the same. Remember we said our diagonals have to be equal in length. So we can say QT, it's equals to, where's QT? This is QT. It's also equals to, you can say RT, it's fine. Like that. So we have this part over here. This part over here, it's talking about our diagonals having the same length. So we have proved something. Let's change the color. this being equals to that, being equals to that, being equals to that. So our diagonals are equal in length and they cut each other equally like that. All right, let's check, is there something else we can try doing? Let's see if we can find out that this corner angle over here is 90. We know that this is 60, right? This is 60 over here. This is 120 over here, vertically opposite. Let's write that down. So we know that angle T over there, it's equals to 120. Our reason these are vertically opposite, angle like that. And then from there, we can say in this triangle over here, which is TQR, in that triangle, we have 120 plus angle Q over there plus angle R over there. Are we still on the same page?
Yes.
Yes.
Right. But angle Q, it's equals to angle R because these are now angles opposite equal sides. These sides are equal. So angles opposite equal sides are equal. So we can now say, okay, this was equals to 180 sum of interior angles in a triangle. So we can say here it's 120 plus 2Q is equals to 120. We have 2Q is equals to 180 minus 120. We have Q being equals to, this is 60. We divide by 2, we get, what do we get? 30, right? Are we still together?
Yes.
So this calculation was just for us to get 30, which is this angle over here. So this angle is 30, this angle was 60. That means this entire angle is 90. So we can say, therefore, angle Q, it's equals to 90 degrees. It's 90 degrees like that. And if it's 90 degrees, we have proved the one of the corner angle being something, something. Let's see it. This one, we have proved it. We have proved this one as well over here. Let's check if the opposite sides are equal. Okay, that one is true because this was given as a parallelogram. So we know that this guy is equals to that guy and so on and so on. All right. And yeah, that's about it. Any questions on that one? Any question on that one? Just to highlight the procedure we followed, we first highlighted that this is a parallelogram. We indicated what we know about a parallelogram. Opposite sides are equal and parallel. That proved everything about this one. And then we moved on. We checked if our corner angles are 90 degrees, and that proved that was proved over here. We checked if our diagonals are equal in length when they bisect. We got that one over here. And let me see, are we missing something? Are we missing something? I'm thinking we are missing. Are people still here? Hello?
Yes, sir.
All right.
Yes.
We are still here.
We are missing that PQ is not equals to QR. We need to prove that this side is not the same as this side. Yeah, that's one thing that we're missing. So we can say in triangle PQR, triangle PQR is like this. It's a right angle triangle. That's P, Q, and R. We know that this is 30. This one, we got this as 60. So if it's like this, we can say PQ is not equals to QR because this angle over here is not equals to that angle. The reason for that, angle P is not equals to angle R, not 30. So we cannot say that these are angles opposite equal sides. So if they were equal, then we'd say these are angles opposite equal sides. So these two sides are not equal. So that's another proof we can add there. So these two sides are equal, but these two are not equal. I hope that makes sense.
Yes.
All right, let's see if we can add one more and people can go and write homeworks. Okay, let's do this. So here we're given, this one is a bit long-ish, but let's see. So here we are told that A, B, C, D. So A, B, C, D, like that, is a parallelogram. The other one, it's gonna be, let's see, A, B, O, E. So it's A, B, O, E, like that. It's also a parallelogram, right? We are supposed to prove that, will green be visible? We're supposed to prove that this one, what did it say? EAOD, EAOD, we're supposed to prove that this one is also a parallelogram. So as you can see, this is looking very horrible so far. Okay, so let's just look at it one by one. So for the blue line, that's A, B, C, D. This is what we have. That's D, that's C, that's B, that's A. It's a parallelogram, so we know that these are parallel and equal, like that. So that's equal to this. This is equals to that. So this is for the blue line over here. And then if we check the red line is like this, something like this. This is E, this is A, this is O, and this is B over here, right? So if it's a parallelogram as well, we know that this side it's equals to that side, this is parallel to that, this is parallel to that, and equal to that, like that, right? Now we're supposed to use all of this information that we have here to check if this green guy is also a parallelogram, right? So for it to be a parallelogram, we just need to prove that we have parallel sides. We have a pair that is parallel sides, and maybe parallel and equal sides. Let's see, like that, right? So if this ABCD is a parallelogram, like we did over there, this is what we have. This is what we know. All good, right? For EO, BA, like this small one, this red one in red over here, we also know that this guy is parallel to that line over there. So what we can say is that AB is parallel to CD. We know that. We have highlighted it. We also can say that EO is parallel to AB. Therefore, if you can check here, most of these proofs are just checking that if A it's equals to B and B it's equals to C, then that means A and C are the same. That's what we are doing here. So we are saying that AB is parallel to CD. So AB is parallel to CD. And we are saying that EO, this one is parallel to AB. So that means we can now say CD is parallel to EO as well. That means this guy is also parallel to that guy. All good? Does that one make sense?
Yes.
Please repeat again.
So we are saying that AB, this line, is parallel to that line on ABCD. Happy with that one? This is what we have, right? And then we are saying on this red one, we are having EO, this EO being parallel to AB. This is AB down here. This is what we have.
Yes.
And then if we are going to use the logic that if A is equals to B and B is equals to C, that means A and C are the same thing. So AB is equals to, is the same as this AB. That means these two have to be the same. This is what we have here. CD is parallel to EO. So that means this side is parallel to that one. It's also parallel to this one over here.
Oh.
All right. So that means we have this side being parallel to this one. We can draw a Z over here. So we have that angle and that angle over there. And what's that angle? We have this angle and that angle. What does that give us? What does that give us? These are already parallel lines. What does this give us?
Yo, ayisem nangibona u-N lana.
Alternate.
Yes, that's what I'm asking for. So we can say angle EOD, it's equals to ODC. These are alternating angles. We have proved that EO is parallel to CD. Right, that's the first part we can do. Next, for this to be a parallelogram, I need to prove that this line is parallel to that line. And for me to do that, let's see. I need to prove that this line is parallel to this line. For me to do that, I might need to, let me see. I think we have two ways over here. We have two ways we can approach, but let's look at one. I'm trying to see if this and that could be the same. Any takers?
Sir?
Anyone who has an approach that we can use to prove that this guy and that guy are the same?
No.
All right, let me show you first. So if we'll check, we already know this angle is the same as that angle. All good, right? Now, can we say something about, what can we say about this? What can you see here? It's in green. I'm not sure if it's visible.
Corresponding.
Corresponding. So this and that are corresponding. So we can say angle AB.
Eziphi correspond askisi
This and that. Remember we said AB was parallel to this line. So this one and that one form an F angle. There's an angle like that over there. Can you see it?
Oh, why imagine? Mara ngiyayibona.
All right, so we are saying ABO, it's the same as this angle EOD, like that. And then we're saying those are corresponding angles. So we now know that this guy and that guy are now the same. Right, all good?
Yes.
Okay. Now, if we check in quadrilateral, what's this? EOBA. If we check this one over here, this angle, this corner angle, and that corner angle, what can we say about them? What can we say about this? I think we used it somewhere. This angle over here and this angle, yeah?
Esingathi eka O1.
Oh, one way here.
Oh,
Or here.
angisho sekona lo.
Now, Ola, yeah?
Oh, so le angle lena nale angle ka E.
Lena, lega, E, yes.
Say alternate N.
N, but asazi ukuthi le line lady naleli is parallel. That's what we're trying to figure out. So what I'm asking is, this part, this guy over here, lega B, nale elagu E la, ekhoneni. What can we say about it?
B.
This is the shape we have, guys. This is
Oh.
B, this angle over
That
here,
they
and this,
equal.
they're equal, right? So we can say that AEO is equals to ABO, something like that. Then the reason for that, we can say that thing of opposite angles,
Yeah, but
parallelogram or a quadrilateral parallelogram. So opposite angles of a parallelogram. Opposite angles here of a parallelogram. So now what we know so far, let's just clean this up.
So, is it necessary for me to say angle AEO is equal to ABO, or I can just say angle E equals to angle B?
The thing is, if maybe you forgot this statement, I wouldn't know which E you're talking about. You could be talking about this whole E, but if you have written that in this quadrilateral EOBA, this one, then I know that you're talking about this E. Then you could have said E, it's equals to B, because this one is for only this section over here.
Okay, thank you.
All right. Right, so let's write down what we know. So we know that this angle over here is the same as that angle. We just proved it. We know that this angle over here is the same as that angle. We proved it somewhere, corresponding angles over there. So now, if we have this angle being the same as this angle, that means these two are alternating angles. Then we can say, therefore, angle AEO, it's equals to angle DOE, and then this was proven somewhere. We proved it because we were able to say this and that, or we can just say both are equal to this guy. So reason could be both equal to that angle. Can use that. So both equal to what's that angle? ABO. So both are equal to ABO. So if we can say that, then we can conclude that therefore AE is parallel to DO like that. So now we have proved that this guy is parallel to that guy over there. All right. Any questions on that one?
I say we still gonna do more questions, so understand how fine.
All right. Can I just take in one more last question and then people can go? It's already 8 now. Okay, this one is long. That's long. Okay, that's fine. So we're looking at, I think it's number 8 on your questions. this one. So we are told that in the diagram, we are having D1.
They recording le?
Yeah.
Okay. The previous recording say like ayibonakali kahle YouTube.
As in like the text or
Like it blurry kakhulu, like especially njengoba bawubhala la esayidini.
okay, I wonder why is that. Which quality did you select for the video? Did you select 720, 1080p, 4K? What did you select?
No, it had no options or something when I tried picking the quality.
Okay, we'll check here afterwards when we're done. Okay, it's fine. All right, so here we are told that in this diagram, we are having D1, it's equals to D2. So you can see that over there, D1 and D2. And then you're having F1 and F2, they're equal like that. And also we're told that this part is equals to that guy, right? So firstly, you're supposed to prove that this DFC, so DFCE, this guy is a rhombus. So we've done a proof for rhombus before. Let's try and do it quickly. So already if this side it's equals to that side, they have helped us. So we just need to prove the angles now. The angles as well as this guy over here, that this is a perpendicular bisector or something. Let's see if we can do it. So from here, that would be difficult without numbers. Okay, so can we say that this angle is the same as that angle over there? The reason for that, we are having angles that are opposite equal sides. This side is equal to this side. So those angles have to be the same. So we can say FCO, it's equals to, what's the other one? FD, so we can just say D2 is fine. D2 like that. And then we can say these are opposite. Anything else? Opposite, these are opposite, opposite angles. Oh, angles opposite equal sides. Sorry. So it's angles opposite equal sides, like that. So it's angles opposite equal sides. So that means this one is also like that. And then next, what can we do again? What can we do? We're done with this one. All right, okay, that's fine. So if this guy is the same as this guy and this guy is the same as that guy, can we conclude that these two are parallel? Make sense? So for that one, we'll say since FCO is equals to D2, therefore FCO is also equals to D1, like that, because both are equal to D2. These two are the same, like that. So we have this. So we can say these will be alternating angles, so that this will be parallel to that. So we'll say DE is parallel to FC, like that. So we have that one proved to that side. Okay, let's see what else can we do. Using these angles, this angle and that angle over there. What can we do? Hello? There's still people in the squad. Hello?
Uyazwakala.
Oh, okay. People are super quiet now. Okay. So we can do the same for these stars. We can do the same, then that will help us prove that this one and that one are equal. Let's see if we can do that. So what we know so far is this. This angle is that one. And what do we know about this angle? We only proved that this one is parallel to that one, so we can't conclude about that angle. Okay. I'm trying to see how we can use maybe congruency for something over here. Trying to see if we can say this triangle is congruent to that triangle over there. Now I'm missing this angle over here. All right, it's fine. Let's do this. So remember we said that this angle and that angle are the same, right? Happy?
Not happy, but okay, sir.
So we are saying opposite angles are equal over here. So this guy and that guy are equal. That means this will also be that dot over there. All good? If we are saying this or this whole angle is 30 and this guy is 15 and that other guy is 15 and we are saying this whole angle is also 30, this guy is 15, what will this angle be for it to be 30?
Fifteen.
15. So that's why I'm saying that this and that are the same like that. Right. After that, we can prove congruency. Why am I erasing things? But okay, it's fine. We've already proved this. After that, we can say that in triangle, if you're checking this triangle over here, which is triangle.
What did you get 30 now?
No, it's just numbers. I was just trying to show you that if this whole angle is 30, this one is 15, that one is 15.
Okay.
This whole angle is 30. I was just trying to show you the, yeah.
Okay.
Not that we have 30 anyway. Okay. So this and that are the same. Good. So we're saying that in this triangle DFC and triangle DEC, let's make it like that, DEC. So in those two triangles, let's see what we know. We know that we're looking at this red triangle over here and the green triangle below. So what we know that this angle and that angle are the same. So we know that D1 is equals to D2. So this one was given, can do that. And then we also know that the side over here, DC, is common. So DC is available on this top triangle and also on the bottom triangle. Also, we know that C over here, we can call this C2 and C1. So C1 is equals to C2. This was proven somewhere like that. So here, this is an angle. This is a side. This is an angle. So we can say, therefore, triangle DFC is congruent to triangle DEC. The reason for this, it's angle, side, and an angle, like that. So if that's the case, remember if we're saying things are congruent, we're saying that if I'm gonna cut out this piece over here, I can paste it directly over that piece. So if that's the case, that means I can now say that DF, it's equals to EC. That means this side is the same as that side. And we can also say that FC, it's equals to this side over here, which is DE over there, like that. So all the sides, we have shown that they are equal. We have also shown that the angles are, what's this? The diagonals bisect the angles and cut them into equal parts. What else did we calculate? Yeah, I think that was about it. Right. So we can somehow say that this is a rhombus. Any questions for that one? People are leaving.
No.
Okay.
No,
Next, we
sir.
are told that the circumference of that rhombus is 68 centimeters. And then we are told that DO exceeds the length of OF by 7. So where's DO? DO is this one. So it exceeds the length of OF by 7. So if we can say this guy is X, this will be X plus 7, because we're saying it exceeds this guy by 7 centimeters, like that, right? And then we are told that the circumference, so circumference, we usually use this word on circles, but we're actually talking about the perimeter over here. So the perimeter is the distance from here to there, to there, to there, and like that. So they're saying that is 68. So if it's 68, that means for one side, we can say 68 divided by 4 and get that one side, which will be how much? I think it's 17. So the length of one side is 17 centimeters over here, right? So they said that we're supposed to find the length of DC. Where's DC? DC, this is the total length, as well as the length of EF. This is EF. And then they told us that the hint over here, supposed to let OF to be X. We've already done that part. Right, let's see how we can tackle it. One thing to remember is that we are dealing with right angled triangles. So it's not supposed to be a train smash. This is right angled because we said for our rhombus, our, what's this? Our diagonals, they bisect or intersect at 90 degrees, like that. So we can check, we can use this triangle over here. So we can say, let's see. In triangle DOE, we can say, how do we do Pythagoras again? So our longest side will be DE. We can take DE squared is equals to OE squared plus DO squared. Everyone happy here?
Yes.
All right, so the triangle we are working with is like this. For the hypotenuse, you're having 17. For this side, you're having X plus 7. For this side, you're having X. This is your 90 degrees. It's just plugging in values and that's it. So DE squared, it's 17 squared. Plus OE is X squared. Plus equals to. And then this is X plus 7 all squared, like that. So 17 squared, what do we get? $17 squared.
$289.
Okay. Plus, and then opening this, we're going to open two brackets and so on and so on. You'll end up with X squared plus 14X plus 49, I believe. So this is 289. It's equals to 2X squared plus 14x plus 49. And then you can rearrange things here. 2x squared plus 14x plus 49 minus 289 equals to 0. Everyone okay so far?
Yes.
All right. So this is just 2x squared plus 14x. What's 289 minus 49? I'm thinking 240 equals to 0. You can divide by 2. We have x squared plus 7x minus 120 equals to 0. You can look for factors here. So this will be x and x, factors of 120, such that when we add or subtract them, we get 7. 120, we have, how do we get to 120? Factors of 120. 120 and times 1, we have 60 times 2, you have 40 times 3, and then you have what? 30 times 4. Do you have anything that to do with 5? Twenty times 6. What else? We have 8 times, is it 15? Can we get that? 8 times 15, we get 120.
Yes.
So that means I'm thinking those would be our factors. So 15 and 8. The sign here is minus. So the signs are not the same. Here it's a plus. The biggest number is here, minus, like that. So I took 15 and 8 because if you're gonna subtract those, 15 minus 8, you're supposed to get 7. So carrying on, we have x, it's equals to negative 15, or x, it's equals to 8. So we have to take 8, not negative 15. We are dealing with distance here. Distance cannot be negative. So now we have the value of x, which is 8 centimeters. Our question was asking us to find the length of DC. So DC is from here to there. So that means you'll have x plus 7 and another x plus 7 over here. So DC is just 2 times x plus 7, which is 2 times 8 plus 7, which is just 2 times 15, you get 30. So this is 30 centimeters for that one. And then what else we're supposed to get? EF. EF is this guy. So EF, it's going to be 2 times x, which will be 2 times 8. And this will give you 16 centimeters. That's all we're supposed to do. All right. Any questions?
No, sir.
Okay, we'll continue tomorrow. Sorry for going overboard. We'll continue tomorrow with a different set of questions. I'm hoping people are gaining something. And then you said something about the YouTube videos not appearing, the quality being weird. Let's see. Is it all videos or just the one from yesterday?
So yesterday
Just the one.
was okay.
Yesterday it was?
Okay, sir.
Okay, let's see, HD. Yeah, so you do have, I do have options over here. I do have options up to, it's in HD right now. And I think everything is appearing okay. All right, we'll continue tomorrow then.
Okay, sir.
Sure.
So